This is the Quick Start Orientation Guide for VR Template All Blueprints version 2. This was created using a locally compiled version of the editor. If your game gives you flack about opening it, just have it changed to 4.25. If that's not working for you, just go straight to the Epic launcher. Make sure you've got 4.25 and launch the editor and then open the project files from the editor. And that should get you squared away. Okay, first let's talk about folders. Over here on the left, under Content, we have 2021. That's where everything I've made goes. Um, Virtual Reality and Virtual Reality BP. These are the official Epic blueprints for their VR template in case you need that for some reason. It's not too large. Okay, so moving through, we've got some art assets that happen to be in here, some stuff for the hands, mostly having to do with animations. The two major blueprints are the item blueprints and the pawn blueprint. Got nothing in environment. In framework, we've got some of this game mode and player controller stuff that helps to enable multiplayer. And for maps, we've got 4 maps. The listen start map is what will run when the game is started from a compiled game, and that will look for any servers on your any listen servers on your local network, and if there are none, it will start one and it'll bring you to this map eventually. So if you want to try out the multiplayer, you just open this twice on 2 separate computers on your LAN, and they should just find each other, and whichever one is first will be the host. If you want to do a dedicated server, it's going to run this first and then hop into this. If you want to use a dedicated server, you need to manually open the IP address that you want. You also need to compile the editor locally to do that. There are guides online for how to do all that stuff. VR template test, that's this map, and the transition map, just transition map. All right, necessary junk. This is all the custom blueprint stuff, mostly structs and enums and good stuff that is very useful, but quickly fills up the other folders, and you may not need to actually access them all that often, but you do need them. Okay, without further ado, let's take a look at the pawn. Okay, and we'll start over here. We've got several items that will help you to debug. It shows you if you make these visible, and I guess they should be visible in your version. I just turned them off for the recording of the demos. You'll be able to see where the various components of the pawn actually live when they're sleeping in their blueprint. Moving right along to the event graph. Okay, in startup, we have not first, but the first thing I want to talk about is it checks to see if the world gravity override is on or not. This is something you can select from, go to the map, go to world settings, and then you just click under physics, override world gravity, click, and you just let that stay at 0, and that'll be the same thing as turning the gravity off. If you want to do your own custom gravity, physics, whatever, well, just fix this first, because that might interfere, and then see where this is getting looked at and figured out. All right, so all of this is called after the pawn is spawned, and basically it gets some of the variables set up. For instance, checking which kind of system you have, setting the proper offsets for your hands, setting up some of the button things that might be different for different systems. And it's also going to do some multiplayer stuff. And what this multiplayer stuff is, this is just updating the state of the all the items that are in the map. And it does that as soon as you spawn in. It quickly goes through all the items. Actually, it's not that quick, but it goes through all the items and it puts them where they're supposed to be and in the proper state. Okay, on tick. our first branch is locally controlled. This means that if the copy of this pawn is owned by the person who is running this computer, then it is locally controlled. If this is a copy running on someone else's computer, well, it's merely a copy. They're just seeing the things that you do. And so when they see that, what they get is they just apply the transforms that you set up and interpolate them a little bit so it looks a little bit smooth. So they see you moving, and that's um, replicated from over here. We just gather a bunch of variables, set them on the server, and then um, the variables are automatically replicated to your peers, and then your peers uh, take what's in those variables and use it to apply transforms to stuff in your pawn. And then here, the very last thing, debugging. This is just a bunch of helpful junk that you don't necessarily need. Okay, more stuff that's happening near the end is we're making sure you don't have any angular velocity. If you want your players to be sick, you can go ahead and turn this off and let them tumble all over the place. I think that's pretty horrific. Some stuff making sure that your physics is set correctly. Okay, and then here's all the important stuff. And I've separated it out onto different graphs. And you'll notice some of these are not here because some of these are not called on tick. They're called from other graphs, but we'll go through all of them. So first, get inputs. Let's scroll out. We got two types of inputs. We have polling inputs for things that we're checking continuously every tick, like the axis values for your thumbsticks and your triggers, etc. And then these are interrupts that only happen when the event is fired. So you press the space bar, for example. I don't have it set up to do anything, but this is where you would set it up to do that. And then here's where I already have it set up to do some things. Some grips and triggers have the option to be binary, meaning that they don't take an axis like as a float value. They take either on or off, and I've got it set up so that it treats them as if they are really an axis, and it just sets it to 1 or 0. So it just kind of converts that binary into a float so that we don't have to do it later. Okay, going back here. Okay, those are all the inputs. Then we're going to apply the inputs. I'm going to zoom out here. So, and then I'll zoom back in. Depending on whether or not world gravity is overridden. So if it is overridden, that's basically saying that there's no gravity, or at least in the framework that I was using, which means that you have both thrusters and brakes as shown in the demo. If you don't have it on, then that means teleportation and jumping are both enabled, and that's elsewhere on this page. And jump, of course, doesn't need to be called on tick. It's called anytime you press the jump button. But I just figured I'd keep this here so that you are aware. And then rotation and locomotion are the same whether or not you have gravity. So these are the 6 subroutines that are applied from your control inputs all the time. So this is just how the rotation works on the different axes. Only one of them works at a time, and then only your yaw axis actually works when you're walking. Locomotion for your 360 locomotion. This is where you can change how the controls work for that. I added this recently so that you can control a little bit of where you're jumping to. I don't actually like exactly how that works, but you can mess around with that. Jump is pretty straightforward. Teleportation just checks to see if your teleport button is on, and if it does, it scans for a target. And then once you release those buttons, it just teleports you to the next target. Okay, your hand thrusters, this is where the thrust is applied. This over here is if you happen to be in a ship or something and it's moving and tumbling. This will help you to boost away from the floor and not just keep getting whacked by it. Again, you can change the controls here. Brakes, similar kind of thing. Change the controls, and there's 2 different kinds of brakes where you either brake immediately or brake gradually. For example, if you're in a ship, if you want to match the ship's velocity rather than braking in world space, you would get all that done over here. Okay, back to the event graph. So we did inputs, getting the inputs, applying the inputs, body move. This is the most complicated thing on here, even though it's probably the least complicated looking. This is where all the rotation is applied. So before we looked at rotation, I'll zoom out here. This is really just taking your control and then whether or not you have it on smooth or I call the other one chunky, but I guess it would be like discrete um, rotation. It figures out the degree to which we will be rotating. That rotation is actually executed here on the body rotation uh, subroutine on the movement graph. And then this is so that if you're in 0G, you continue moving while you're rotating. Moving right along. So mag foot anchor, that means that you're walking, even if you're in a level with gravity where this should basically be on most of the time. Um, we still use this terminology. So I'd just say that if you're walking either in 0G or in gravity, that your anchor's on. Okay. This I've marked math. I'm not going to open that up because it's embarrassing displaying my lack of math knowledge, how I get the rotation to work. Um, as your foot moves, it snaps your body to it, and then it checks whether the foot should move again. Here, after the body has moved, the camera moves to follow it. And here, if the camera has moved, um, the head moves to I'm sorry, the body moves to follow the head. So really this is showing that, so we've got room scale movement, which means that you've initiated it by moving your head in real life, and in this case the body follows you. And here we've got body movement, which is initiated by locomotion, for instance, where you want your camera to follow your body, or else you just sort of stand there watching your body run away from you, and that would be a bit silly. One of the interesting things in here is called the VRO offset, and I think I actually have a real, yeah, the VR origin. Um, this is this stays this in the same spot in real space. It'll stay in the same spot in world space when you are walking room scale, but as you're walking in locomotion, this will actually move, and this just recalculates that offset, gets it in the right spot as you do one or the other. Now, if you later want to modify much of the movement stuff on the other graphs, I don't recommend modifying this graph directly. If it's not working right, I would try adding in one of these or multiple of these in various different orders until it just works. I'm not really smart enough to give you better advice than that. All right, moving back to the event graph. Okay, that was the hard part. Okay, so the body moves. Next, we check the body collision. And what we've got on this page, I know it's not very neat to look at, but what we've essentially got are different collision checks. One for the head, one for the body. This is a lean check to see if you're leaning over a table or something. Typically, your body will follow you, and that'll just be you'll just be blocked by that. But if you want to lean over a table and let your head go a little bit over the table without having your body follow you, but also without having your head snap back, this is what checks to make sure that's going on. This checks underneath the foot. And gosh, what is this one? This also checks underneath the foot. These are different. This one is the initial one to see if we can clamp, and then this one gets called every tick to if once you're already clamped to see how we should be moving. Okay, I would go through these, really dig into the functions here because they get a little bit complicated. This is just where they're called on tick. Moving back to the main event graph, adjust body. This one's pretty simple. This automatically updates your height in game. I got sick of using the different origins and, well, what happened if my thing was miscalibrated or if I started with my headset in the wrong spot. This will just figure out where you are when you're the tallest and call that the max height, which is a variable in here somewhere. And this will actually set you at that height. If you happen to be flying, your capsule will shrink so that you don't hit yourself on the um, bottom of things when you're like trying to fly through doorways and stuff. Okay, that's the body. Now we go to hand stuff, basic hand stuff. This is where, in 3 phases, we decide what the hands are trying to do and what they may actually do based upon their state. This, although is complicated here, it makes it much easier down the line if you want to change how hand state transitions work, because you can just change it in the one place, in one of these places, and then everywhere else down the line, it doesn't care how you got to that state. This updates the hand animations. This updates some state variables. This is for collision. Again, these are based on these are action targets actually, like what you're trying to do, not necessarily what you are doing. And these send some updates which are helpful for replication and for talking to items. Okay, so that's the basic hand stuff. That's the easy part. The hand actions are a bit more complicated. So one of them is collision. So depending on your state, you'll have different kinds of collision. Additionally, if you're already holding an item, I let the item control the collision so that you don't have to have a million different variables over here. Just have the item on tick call. In this case, I have 2 kinds of collision set up, normal and just none. But if you, whatever kind of collision you want when you're holding an item, you can have it be called from here. Okay, so we do the checks. This is plane sliding, which means that you don't go through a thing, but you also don't, like if you try to put your hand through a wall, it doesn't go through the wall, but it also doesn't just stop where it is. It meets you halfway wherever your motion controller is. It tries to put that in the proper spot where it wouldn't be colliding. There is actually some built-in stuff in the engine to make this work with physics, with the built-in physics. I did not like the way it worked with the hands, especially since your hands have multiple ways to be configured, like in terms of the grip animation. I couldn't get it to work correctly, so I did it manually, and it's quite complicated and stupid in there. I recommend going and changing this if you don't like the way that hands collide. And then 2 kinds of physics for hands. One is when your hand is open. One is when your hand is in a fist. If you're in a fist, it's going to throw you back and move the item if the item is a physics body. And if your hand is open, it will slow you down. It's not as dramatic. This is because I don't want to penalize the player for accidentally touching a wall or something, because they don't actually get any physical feedback. So it makes more sense to let them know, hey, you are touching this thing, or if they mean to do it, to let it happen. But it's not as dramatic as if they try a fist bump or if they try to grab onto it with their claws. And this is for updating the hand location because it actually won't move unless it's called from the item. So these are both called from the item. One sets the collision, and then one updates the location. Okay, talking about anchors. Anchors is when you use your claws to like climb something. This is where that gets set. Item targeting. This is where it sends out the messages to the items, and it sends it checks with the items like, hey, are you available? If it is available and you happen to be holding down the grip button, then it sends the grip message to the item, and the item responds depending on that item's own logic. And this is similar to the item targeting, except it's for buttons only. And buttons, it basically just continuously tells the button, hey, this is where my finger is. The buttons only work when you have your grip on, and it only takes it from the edge of the pointer finger. This is not the most realistic way to do it, but it is, I think, the best way to do it because your player's not going to have excellent control over their hands, and the buttons are going to be not that much fun to use much of the time. So we want to make sure when they press a button, they've meant to do it. So we have a little, I think, acceptable break from reality there. All right, moving back. Basic hand stuff, hand actions. Okay. So now I want to go through the graphs that we didn't look at. So that would be body special. There are several special ways that the body moves. So one is teleportation. One is has to do with hand anchors. If you're already um, like gripping a wall, this is where it actually makes you move. This is what detects whether you're having a collision with the wall, and so it doesn't bounce you off the wall, it doesn't let you go through the wall, it just sort of lets you slide along the wall. This is the same thing when you're walking. This is if you manage to get yourself inside the wall, it'll bounce you back off. This is the cliff detection that doesn't let you fall off of cliffs unless you want to. You can turn this off, I think, just by setting this to always be true. Or anytime the player uses the sprint button, they're able to jump off. Okay, that was body special. I want to say there's more. Did we go through all these? So control inputs, body movement, yes, UI, and unfortunately I can't reorder these. I'm so it would be better if I could. Body collision detection we did look at. That's the wonky looking one. Adjustments, hand basic. The startup stuff, which I'll go into more detail later. Body special we did just now. Hands actions, yes. Replication we talked about in the beginning. This is if you have some special stuff for your game mode. It'll get called here during startup. I talked about this. This is a special place for any debug stuff, and this is where all the controls live. Okay, I guess there's all that. I've broken down the variables into little places. The ones that you'll want to mess with first are the ones in options. These are the ones that you'll want to set, like how fast does the player go, how tall should the player be, etc. And at a later time, I'll have a video that covers in more detail the various parts of the pawn. I will have a video that covers in more detail how replication works, how this game mode and this player controller work. That'll be part of the replication video. And I'll have another video on how the items work. Each of these really deserves its own video. They're a bit complicated. So look forward to those. Join the Discord, ask questions in the meantime until those come up. If you subscribe, I think it'll ping you when I put up new videos. I don't make money off it or anything. That's just a way for you to keep up to date with when new videos come up. All right, I hope you enjoy it. Thank you.